Hi there, this is Amir from Simra Tech, and today I'm going to show you how you can do your layouts with Simra. As for testing, we have this differential OTA is done by Chair of Professor Prettel at JKU, and the PDK they used is the Open PDK from IHP. It's a silicon germanium high-speed PDK. And I'm gonna start to use voice mode with Simra and describe what we want. Yeah, and we can go from there. So we have this differential OTA. It looks like to be two-stage, and I want you to start laying out for me the differential pair. And while you do the differential pair, I want you to also start planning the routing of the signals and the supply rails so that in next steps we can start putting the devices surrounding the input pair with ease. And also, um, well, I don't know if this is for a lower speed kind of high accuracy or for high speed. So we want to also be be careful about it, especially if it's high speed regarding parasitics. But if it's lower speed, then we take care of the noise and stuff. So I want you also to think about it, come up with the strategy, and of course it's an analog layout, so there are principles for analog layout that you need to adhere, not only the what the application is. So with that, yeah, go ahead, do it, Simra. Just give me the input pair, okay? And also, once you're done, open me the K layout, uh, and I want to see the layout. Okay, I think I talked too much, but let's see what comes out. I just pasted the whole transcript of the conversation and let this run. All right, it came back with the result. We can see that to satisfy both low speed and high accuracy for noise and systematic mismatch, uh, deploy the unified analog layout strategy. So basically, command mode interdigitate topology. It added also a dummy. So we have dummy, then we have A transistor 1, A transistor B, and then we have B transistor 2, B transistor 1, kind of a sandwich with a dummy on the surrounding. It added the dummies also and created a CDL to be able to run the LVS. It shared the diffusion between the between transistors, like when they're source and drain, they can be shared. Of course, it should do it. It does a planar crossover prevention. That gate of M1 are connected with horizontal metal one rail nested on top of gate extension. So let's take a look. Here I have the input N at the bottom, and it's a metal one. Okay, it's kind of like in an island. I don't like it. I probably it should be metal too, so I don't need to. Well, we can ask that. And then we have input P here, and this is like the intermediate stuff. We can see like the dummies are placed correctly. Um, okay, so like also I see like the diffusion is not really sharing, like it needs to cover over it. It managed to get a DRC clean, but yeah, it doesn't look good. Like we can remind of that. And yeah, it has also, like you can see, the DRC run folder, LVS run folder. This is all the logs that it ran and has this result for us. So um, well, it took 10 minutes. Uh, it would save my time. Like it's faster than if I would have wanted to do it by hand. And it's just the beginning of how we are exploring the analog layout. And of course, there is a lot of knowledge that you have that needs to go into your layout. So naturally, we cannot make Simra to know already the knowledge that you have in your analog layout. That's why the way I try to show how to work with Simra is that imagine it like a junior colleague sitting next to you, and you're just working with it. And the thing is, it took 10 minutes to do this. 10 minutes, I could have do as a human many other things in parallel. I could have like, I don't know, 5 Simra at the same time doing things or doing things that are necessarily not with agents. So that's the thing I want to bring you to understand how these agents can come into our workflows and give us value. And like, of course, it's not a perfect result, but we can get there. It takes time. So, okay, Simra. Well, it kind of looks good. One thing is that the input P and N, you put it on metal 1. I would have preferred to bring it to metal 2 so I can easily route it out from the surrounding metal 1 supplies and other internal wires. And another thing that I would like you to do is that I need to connect tail as well. So can you also bring tail to metal 2? And I don't like to just have one via. It's a little bit risky. Can you put minimum of 2 via? I'm not sure for the gate if you can do that, but maybe you need to extend it. And also the for the grounding, you put these tabs around, but it doesn't seem to be fully covered with the supply metal 1 uh, metal you put there. So can you please align them correctly? Okay, now I just gonna paste the transcript and we can let Simra run another round. Okay, so Simra is back. Now you can see the updated layout. It added uh, two vias here for the gates as well as here, and it brought it directly to metal layer 2. I have also detail also with 2 vias is on metal layer 2, so I can easily route it out over the supply. It also fixed the issues I had here. I'm not sure why it left a gap here. Uh, it it could be like we could also route some bus from here. It's not like maybe like 1-2 signal. If it's like really you don't want to pass it over VSS for any type of interference from it, maybe that's for the reason. Or we can add some shielding. But because of the dummy, I'm not really concerned about this having a little bit of space on the right side. But if you don't need it and you think it's not necessary, just ask Simra to bring it back where it was. Um, yeah. So and it did also all the DRCs and LVS, and you can see here we have the input per CDL, we have input per GDS, the schematic, the symbol, which was from the source files. We have all the Python scripts, which it did use to do this. And then there is a DRC and LVS run folder with the CIR format files, the LVS-DB, and all the logs from LVS. It did run, I think, 10 times LVS in the loop to come with a clean LVS. And that's the thing. Like I did analog layouts. Like I like the part of like architecture and thinking, like and like having like a base unit and then like putting kind of mask on top and like do this kind of things. But I really hated all the run the DRC, read the errors, like, oh, there is like one little corner, just put like a rectangular there, solve that. And then for LVS, sometimes like you don't see like the stupid short you made on a metal, and we need to spend like hours and like kilos of coffee to get that going, especially when the design gets big. Is it small? It's manageable for human, it's manageable for agent. But the thing is that like when data grows in size, like still it can be manageable for agents on the same level, because it can parallelize like the analysis that it does. It can spin sub agents and analyze it for you. So it like as complexity grows, like these panes grow, but the agents can still perform how you can see on even a small layout. And from here on, like I can continue the conversation with Simra to put the, let's say, we have like the devices that I could go put the PMOS pair on the load, or we go with the common mode feedback resistors and the network there. Yeah, there is a bunch of stuff we can do from here. And I try to start with input pair. That's like one of the most sensitive pairs. So you want to do it right. And usually I would start from input pair. So that's why I went with Simra. And the thing is like you do it how you works for you. You know, you did your tape outs, you have silicon proven designs. So nobody in the world knows better than you. Probably some people know better than you, but not everybody. Uh, yeah, it's just like it's a very our industry is everybody has their own kind of like tribal knowledge, and like agents don't know those stuff, and you know it. So you can give it to your agent, and we also can use for example, I'm gonna use learn. We had this before in one of our videos about like learning workflows. Now you can with a comment put learn, and I put learn and say how we did input pair of low noise water layout. Okay, so now I put it to learn this, and from now on, anytime you have any OTA or any other block that you want this input pair to be with these principles, then you just ask it and it will fetch it from, it's learned the skills, and it's able to do this whole thing without you telling it, okay, you need to put two vias, you need to bring it to metal 2, and there's all the stuff that you're gonna put on top, like I don't know, you want to have it buses or um, shielding and other things. So yeah, it did create like a EAP 130 low noise OTA layout, and in the category of the Open EDA, which we created for the open source tools, and it cached the okay common centroid, cross-free routing and shielding, physical root compliance, and EDA LVS verification secrets. So there are some stuff. It did 10 LVS, it learned some stuff. So next time it's not gonna take 10 minutes to do that. It's gonna be much faster. Maybe next time 3 tries, and hopefully one day 1 try. Okay, with that, I'm gonna close this video. If you want something more to see, like a layout of like, I don't know, mixed signal stuff, like some specific thing we could do, like analog extraction. We could, for example, get an estimate of the parasitics, the resistive sheets, the parasitics between signal paths or supplies. We can use that, come on a higher level of layout to use Simra to help us with planning. It has access to the PDK. It can have access to any PDK that you have locally in your server, and in our sandbox it has access to the 3 open PDKs, and it can go and calculate you all the stuff that you need for estimations and planning. Okay, with that, I hope to hear from you soon. Let us know if you want to play with the sandbox.